Hey friends, welcome to Simplified by Singham. Well, today we are going to learn something that's not just important in programming but also in mathematics, which is the GCD or greatest common divisor. Let's go step by step, and I promise by the end you'll completely understand it. So let's understand what is GCD in math. Well, GCD is actually a greatest common divisor of two numbers in the largest number that divides both numbers without leaving the remainder. And you'll be like, what are you saying? I didn't even get a word. Don't worry, I'm going to explain it by giving a good example. Let's take two numbers. And we have two numbers. Let's say 48. And let's give it. What are the common divisors of 48? So 48 is divisible by 1, 2, it is divisible by 3, it is divisible by 4, and then 5, no. 6, 7 is also no, then 8, and then again directly it will jump to 12, and 16, 24, and 48. So these are the numbers that are divisible by 48, right? And also let's check the common divisors of 80. So for 18, it is divisible by 1, it is divisible by 2, 3, 6, 9, and 18, right? So in between these two, if you check the number, the divisors, what are the common divisors we have? So common divisors of 48 and 18. Common divisors of 48 and 18 are, let's say it is divisible by 1, both are divisible by 2, both are divisible by 3, both are divisible by 6, right? And I think nothing common other than that. Out of all these numbers, what is the largest common divisor? Which is 6. So this 6 is nothing but GCD, greatest common divisor of 48 and 18 is 6. So this is what GCD is. So GCD is used in many real life situations like simplifying fractions, when dealing with cryptography, and even with computer algorithms. Okay, now let's see the flowchart. So how do we calculate GCD without listing all divisors? So that's where this Euclidean algorithm comes in. So the flow chart will work something like this. Don't worry about the algorithm. Don't worry about the logic for now. Just blindly follow me. We will go step by step and we will understand the logic. So we will start, we will get two numbers from the user A and B. And while B not equal to 0, we do this process. We create a temporary variable and we add temp and we add A in that. And then we add B in A, and then we are doing some temp mod B. And until B not equal to 0, you are going to perform this operation. Once B, so while B not equal to 0, you will create a temporary variable, you'll add A in that, and you'll add B in A, and then you calculate temp mod B and store it in B. So once it is done, it will do, this loop will be done, and once it is true, it is going to get the GCD and then it will end. So this is how the expected output looks like. You'll get the first number, second number, and you'll say GCD of 48 and 18 is 6. Do you think it's easy? Yeah, if you blindly follow this algorithm, it's pretty simple. All you have to do is get two numbers and follow the logic which is already there in the flowchart. Okay. Let's blindly follow the flowchart for now, and later while tracing you will understand the logic. Don't worry about that. Now, always get user input. A equal to int of input. Enter the first number. B equal to int of input. Enter the second number. And now let's blindly follow this logic. While B not equal to 0, just create a temporary variable and add A in that. And just add B value in A, put B value in A, and then calculate B equal to temp mod B. And then you print the result. The GCD of the entered numbers is, it will be in A. The GCD will be in A. So A. And yeah, that's it. Let's run this and let's see what's going on here. So we'll give the same inputs, 48 and 18. The GCD of 48 and 18, which are nothing but the entered the numbers, is 6. Okay, sounds good, pretty good. And now let's trace the logic. Let's check what's going on here. So initially A value is 48 and B value is 80. Sounds good. So far so good. While B not equal to 0, that means B value is nothing but 18. 18 not equal to 0. True. And now the temp value changes to, what is the value of A? 48. So it will be 48. And A value changes to B. What is the value of B? 18. So here A value is 18. And now B value is temp mod B. So 18. So what is temp value? 48. 48 mod 18. Right? 48 mod 18. So what is 48 mod 18 in the first iteration? Is 12. So here we are actually printing B. So this is what? 12. So here the B value changes to 12. Okay. I think you guys know the importance of modulus operator. It will just give you the reminder. So when you divide 48 by 18, so the remainder will be 12. So that is what you are seeing here. So initially B value is 12. Okay, it will print the B value and now the loop goes again to here. Now the B value is 12. So changes from 12. Is 12 not equal to 0? Yes, true. So now again, the temp value is A. So what is the value of A now? Listen to me. What is the value of A now? So the value of A is 18 now. So temp value changes to 18. And what is the value of B now? A equal to B. So B value is 12. So now B value is 12. And B equal to temp mod P. So what is the value of temp now? 18. 18 mod 12 is nothing but 6. So when you divide 18 by 12, the remainder will be 6. So this is what you're going to see, which is 6. Now this value is 6. Okay, fine. And now it will print B and now again it jumps here and the value of B is now 6. Is 6 not equal to 0? 6 not equal to 0? True. And now temp value changes to A. What is the value of A now? It's 12. So Temp value changes to 12. And what is the value of B now? It's 12, right? Sorry, B value is 6. So A value changes to 6. And now B value changes to temp mod B. What is the value of temp? 12. 12 mod 6. 12 mod 6. When you divide 12 by 6, the remainder will be 0. So now B value changes to 0. Now listen to me. While B not equal to 0, what is the value of B? 0. And here it is 0. Is 0 not equal to 0? True? No. False. So then it comes out of the loop. And by the time, what is the value of A? 6. So that is what the GCD of entered number is 6. We are simply creating a temporary variable and we are adding A in that, and we put B in A, and then we are doing this modulus operator, and then we are printing B, and then we are finding the GCD of a number. So this we call Euclidean algorithm. In order to find the GCD of a number, this is the process we have to follow. So basically, why we need this Euclidean algorithm? Because if you observe, the problem here is we have to list all the divisors and then we have to pick the largest divisor out of it. So listing all divisors work, but it's very slow if the numbers are big. Imagine doing this for 2, 4, 5, 6 and 789 number. So that's why Euclid came up with a smart trick, which is 2000 years ago, 2000 plus years ago. Here, basically, we take the big number. It's very simple. I know it's tricky for you to understand when you are a beginner, but I'll try to make it as simple as possible for you. So basically, here we are taking the bigger number and we are dividing it by the smaller number. So take the bigger number and divide it by smaller number. And instead of caring about the full quotient, just focus on the remainder. So that is what we are doing here. Just focus on the remainder and now replace the bigger number with the smaller number and the smaller number with the remainder. You are just replacing the bigger number to the smaller number. That is what we are doing in every iteration. We started with 48 and then we started with 12 and then we started with 6 and then we started it with 0. So this is the loop that we are using. So we are actually replacing the number with the smaller number and smaller number with the remainder. And just keep repeat it until the remainder becomes 0. So once the remainder becomes 0, that last non-zero number is nothing but the GCD of the number. 48 by 18 is 12. And now replace 48 by 18 with, it's something like 48 by 18 is 12, right? And now replace this 48 by 18 to 12 and 18. Just replace 48 with 12, right? And now this 12 and 18. Now when you, now when you do this 18 by 12, then you will get 6, right? And now replace this 18, 12 to 6 and 12 or 12 and 6. And now 12 by 6, 12 by 6 is 0. The remainder is 0. So the remainder is 0 and the last non-zero remainder is 6. So that is nothing but the GCD. So this is what we are doing. We are just replacing the bigger number with the smaller number, which is nothing but the remainder. Instead of focusing on the divisors, we are focusing on the remainder. Like, think of it like chopping a rope into equal pieces, and if you try it with 18 first, you will have some left over. and then you try it with the leftover, and eventually you will find the biggest piece size that divides both ropes evenly. And yeah, that's it. So what if the users give negative numbers? So when users give negative numbers, you can just use ABS method, which helps to make negative numbers to positive. So ABS equal to ABS of A, and B equal to A equal to ABS of A, and B equal to ABS of B. So like for example, if you give negative numbers, then also it will find you the GCD by making the negative numbers positive. For example, minus 12, minus 6. The GCD of the entire numbers is 6. Okay. And let's also remove this. And what if the users give both of the numbers 0? If users give both of the numbers 0, then you can say that if A equal to 0 and B equal to 0, then just print GCD is undefined for 0 and 0. Else, then you make this logic done. Else, done. Enter first number 0 and the second number 0. GCD is undefined for 0 and 0. So the GCD of the entire numbers is 0. Keep this in the same line itself so that it will print in the else part. What if the GCD? So the GCD of the entire numbers is 6. What if any one of the number is 0? 0 and 6, the GCD of the entire numbers is 6. Obviously, the other number will be the GCD. So that's the magic of Euclidean algorithm for finding GCD. And we started with simple math, walked through the flowchart, and finally wrote Python code step by step. If this explanation made you go, oh, now I get it, then don't just leave. Hit that subscribe button and turn on the bell. Think of it as your personal investment into becoming a confident coder, and every lesson here is built beginner first, so you'll never feel left behind. Alright, friends, see you in the next video. Until then, keep coding and keep smiling. If you still have any doubts, please comment down. I'll be always there to look at them, and I'll try to reach ASAP, and I'll try to help you out in the problem that you guys are facing when it comes to coding. Thank you.